Hi everyone. Today we're going to begin on Unit 6, which is called Chemical Reactions. We're actually going to complete a series of 3 lessons on percent composition, empirical formula, and molecular formula. Let's begin by talking about the difference between molecular formula, percent composition, and empirical formula. So we're going to use glucose as our example. So if I write the molecular formula for glucose, I have C6H12O6. When I'm talking about percent composition, what I'm really trying to figure out is, of that molecule of glucose, what percent of this is carbon, what percent of this is hydrogen, and what percent of that is oxygen. If I go the opposite way, empirical formula is the lowest whole number ratio between atoms in a molecular formula. So the empirical formula for something like glucose would simply be CH2O. And you get that by identifying what the greatest common factor is. So in this case, it's 6, and then dividing the greatest common factor through to wind up with your empirical formula of CH2O. Now, we'll talk more about empirical formula and molecular formula in lessons 2 and 3. Today, we're going to focus on percent composition. So in our first example, we are going to be finding the percent composition for phosphorus pentachloride. So the very first thing that you have to do is identify what the formula is for phosphorus pentachloride. So you'll recall from our unit on naming and writing formulas, chemical nomenclature, that penta is the prefix for 5. So this is an atom of phosphorus with 5 chlorines attached to it. Now, in order to figure out the percent composition, we first want to find out the total molar mass for the compound. If you look on a periodic table, you'll find out that phosphorus has a mass of 30.97 grams per mole, and chlorine has a mass of 35.45 grams per mole. However, since we have 5 chlorines in our compound, we're going to multiply that value by 5. So if I open up my calculator, I have 35.45 times 5 for a total of 177.25. Now, I want to find the total molar mass. So I'm going to add up these two numbers, 177.25 plus 30.97. So I wind up with an answer of 208.22 grams per mole. Now, just like finding the percent for anything that we encounter, we're going to put the part of each of these, so phosphorus, over the whole molar mass. Same thing with the chlorine. The part that's chlorine over the entire molar mass. So my percent phosphorus is going to be 30.97 grams per mole over 208.22 grams per mole. We'll multiply that value by 100. My percent chlorine is going to equal the total mass of chlorine, 177.25 grams per mole, divided by my total mass, 208.22 grams per mole. Again, we're going to multiply by 100. So for the first one, we have 30.97 divided by 208.22, multiplied by 100, We get an answer of 14.87. We'll keep 4 significant figures. For the chlorine part, we have 177.25. We're going to divide that by 208.22. And in this case, we can keep 5 significant figures. However, we're going to make it match, so we're only going to keep 4. So we'll have 85.13 percent chlorine. If you have done your math correctly, when you get your final percentages and add them up, they should add up to 100%. Now, sometimes because of rounding, you might get 100.01 or you might get 99.99. Regardless, they should add up to a number that's very close to 100%. So in our case, we add up to exactly 100%. Let's take a look at a second example. So in this example, we're finding the molar mass first for sodium carbonate. So you might recall that the formula for sodium carbonate is going to be Na2CO3. So for sodium, I have a molar mass that's equal to 22.99 grams per mole. I'm going to multiply that by 2. For carbon, I have a molar mass that's equal to 12.01 grams per mole. And for oxygen, I have a molar mass that's equal to 16.00 grams per mole. So in the case of my sodium, I'll get 45.98 grams per mole, 12.01 grams per mole, and finally 48.00 grams per mole for my 3 oxygens. I'm typing this into the calculator. I have my 45.98 plus my 12.01 plus my 48 for the 3 oxygens. So I wind up with a molar mass of 105.99 grams per mole. Now, my goal is to find out the percent for each element. So I'm going to put each of my 3 elements over the total. So first, my percent sodium is going to equal 45.98 grams per mole divided by 105.99 grams per mole times 100. My percent carbon is just the 1 carbon, 12.01 grams per mole over 105.99 grams per mole times 100. And finally, my percent oxygen is going to equal 48.00 grams per mole over 105.99 grams per mole times 100. So for the first one, 45.98 divided by 105.99 times 100. And I get 43.38%. Sodium, 12.01 divided by 105.99 times 100. And I get 11.33. Carbon, and finally 48 divided by 105.99 times 100 equals 45.29%. Again, all of your values should add up to somewhere around 100%. So I'll get 43.38 plus 11.33 plus 45.29 29, and we get 100% exactly. And sometimes with rounding, might be off by 100th, either higher or lower. Okay, let's look at our third example. Our third example is calcium phosphate. I think you'll agree that the hardest part of completing these problems is actually making sure that we have the right chemical formula. So for calcium phosphate, the correct formula is Ca3PO4 in parentheses, and then a 2 outside of the parentheses. So for calcium, we have a molar mass of 40.08 grams per mole. We're going to have to multiply that by 3. For phosphorus, we have a molar mass of 30.97 grams per mole. We're going to multiply that by 2. And finally, for oxygen, we have a molar mass of 16 grams per mole. We're going to multiply that by 8. Again, these molar masses are the mass off of the periodic table. So for the first one, we're going to wind up with a molar mass of 80.16 grams per mole. For the second one, we have 30.97. We're going to multiply that by 2, so we get 61.94 grams per mole. And for oxygen, we will get 128.00 grams per mole. We're going to add up all of our values. So 80.16 plus 61.94 plus 128. So we get a total molar mass of 270.10 grams per mole. Now we need to figure out the percent of each of our elements. So we'll put each of those over the total mass. So for the percent calcium, we'll get 80.16 grams per mole divided by 270.10 grams per mole. For percent phosphorus, we'll get 61.94 grams per mole over 270.10 grams per mole. And finally, for percent oxygen, we will get 128.00 grams per mole divided by 270.10 grams per mole. Again, we'll multiply each of these by 100 to convert our decimal into our percent. So 80.16 divided by 270.10 times 100 equals 29.68. Keeping 2 decimals for all of these, that's percent calcium. 61.94 divided by 270.10 times 100, that equals 22.93%. And then finally, for our oxygen, 128 divided by 270.10 times 100, and we get 47.39%. Then a nice way to just double check your answer, go back and add these up. 29.68 plus 22.93 plus 47.39 equals 100%. Okay, at this point, I would like you to try to complete the assignment on percent composition. Again, if you have any questions, please feel free to reach out. Have a great week, everyone.